Good morning students, this is class 11th maths, chapter 1 sets, book is Exemplar and the lecture is we will discuss the holiday homework. So question second of chapter first is in Exemplar, NCERT Exemplar. Write in roster form, the set D is given in set builder form, we have to write down it in roster form. So D is T such that T cube is equal to T, T belongs to R. R here is the set of real numbers. So we have to find those T such that T cube is equal to T. It means T cube minus T equal to 0. We can take T common. T square minus 1 in the bracket equal to 0. Therefore T is 0 plus 1 and minus 1. Therefore the set D is minus 1 0 1. Next is, this is also easy, we have to find W such that W minus 2 upon W plus 3 is equal to 3 and W belongs to the real number. So W minus 2 equal to, take this that side, so 3 into W plus 3. When you will solve it, you will get W is equal to minus 11 by 2. Therefore, the set E is only minus 11 by 2. Clear? Now, third part, the set F is given as x such that x raised to the power 4 minus 5x square plus 6 is equal to 0 and x belongs to real number. So, this is the given condition. So, solve it. Writing this minus 5x square as minus 3x square minus 2x square. Now from these two terms we can take out x square common. In the bracket x square minus 3 and from these two minus 2 common. So you will get x square minus 2 into x square minus 3 is equal to 0. Therefore x is either plus or minus root 2 and x is from this plus minus root 3. Therefore, the set F becomes root 2 minus root 2, root 3 and minus root 3. Clear? Now, question number third. If y is equal to the set x such that x is a positive factor of the number 2 raised to the power p minus 1 into 2 raised to the power p minus 1, where 2 raised to the power p minus 1 is a prime number. Write y in roster form. So y is what? Factor of the number 2 raised to the power p minus 1 into 2 raised to the power p minus 1. So as we know, any number x has two trivial factors, that is obvious factors, which is 1 and the number itself. So the factors of this trivial factors are 1 and the number itself, right? Now the factor of 2 raised to the power p minus 1 is 2. 1 is also the factor of this, but we have already taken 1. So the factor of this will be 2, 2 square and so on up to 2 raised to the power p minus 1, right? And also factors of 2 raised to the power p minus 1. This is a prime number. So factor of this is 1 and the number itself, right? So the factors of this number will be 1 and the number itself. Then all these 2 square up to 2 raised to the power p minus 1. And because this is a prime number, therefore the factor of this is 1 and the number itself. So this will also be a factor of this number, right? So these are the factors of this number. Now question number 6. If A and B are subsets of universal set U, then show A is a subset of A union B. So let x belongs to A. To show A is a subset of A union B, we will show that if X belongs to A, then X belongs to A union B, which is obvious. When X belongs to A, it implies X belongs to A union B, since A union B includes all elements of A. Therefore, A is a subset of A union B. Second is, if A is a subset of B, it implies, this is the symbol of if and only if, that if A is a subset of B, then A union B is B, and also if A union B is equal to B, then A is a subset of B. So first, let A is a subset of B, we will show A union B is equal to B. To show that these two are equal, we will show that this is a subset of this and B is a subset of this, right? So B is subset of A union B, this is obvious. Now we will show that A union B is a subset of B using this condition. So let X belongs to A union B. It means either X belongs to A or X belongs to B. Now if X belongs to A and the given condition is that A is a subset of B, so X belongs to B, or same X belongs to B. So from both of these conditions we get that X belongs to B. Therefore A union B is subset of B, because we started with that X belongs to A union B, and now X belongs to B also. Therefore A union B is a subset of B. Now from this first and second we can say that both the sets are equal. Therefore A union B is equal to B. Right, now we will show if this is true, that A union B is equal to B, then A is a subset of B. So now let A union B is equal to B. To show A is a subset of B, let X belongs to A. If X belongs to A, then X belongs to A union B, right? Because in A union B, all the elements of A and B are there. So X belongs to A implies X belongs to A union B. And by using third, we can say A union B is equal to B. It implies X belongs to B, and therefore A is a subset of B. Question number 8. If X is equal to the set 1, 2, 3, if N represents any number of X, write the sets for N. Here N represent any number or any element of X. So X elements are 1, 2, 3. So we have to find the set for N. So in place of N, put the elements of X. So 4, 8, 12. And similarly here N by 2. So 1 by 2, 2 by 2 is 1, and 3 by 2. Question number 11th is that U is the set of boys and girls, that is universal set. G is the set of girls, B is the set of boys, and S set of students who takes swimming, right? So we have to show this relation by some Venn diagram. So making Venn diagram, this is the complete universal set. This is the set of girls represented by G. This is the set of boys, right? There is no intersection between girls and boys obviously. So set of girls is this side and set of boys is this side. Now S includes the students who takes swimming. So the students who take swimming can be girl also or can be boy also. So we will draw S like this. Some intersection of S with G and some part of S will lie in B. Clear? Now question number 12. For all sets A, B and C, show A minus B intersection A minus C is equal to A minus B union C. So to show that these two sets are equal, we will show this set is a subset of this set, and similarly this is a subset of this set, right? So first of all, let X belongs to this set. Now to show that X belongs to A minus B union C, then only this will be a subset of this, right? Now since X belongs to intersection of these two sets, This means X belongs to A minus B, and intersection means and X belongs to A minus C. Now A minus B means that X belongs to A and X does not belongs to B, and X belongs to A minus C means X belongs to A and X does not belongs to C, right? Now combining these two results, we can see from these two results X belongs to A and X does not belongs to B and X does not belongs to C. This means X belongs to A and X does not belongs to B. Neither X belongs to C. Therefore, X will not belong to B union C, because in B union C, those elements comes which are in B or in C. But X is neither in B nor in C. Therefore, X will not be in B union C. Clear? So, therefore, from this result we can say that X belongs to A and X does not belongs to this set means X belongs to A minus B union C, because A minus this means that X belongs to A and X does not belongs to this, right? Therefore, we can say we started with this, that X belongs to this, and we have shown that X belongs to this. Therefore, this A minus B intersection A minus C is a subset of A minus B union C, right? Now we will show the opposite, that this is a subset of this. For this, let Y belongs to A minus B union C. This now simply means Y belongs to A and Y does not belongs to B union C. We have to just go the above, the same method, the same process. So Y belongs to A and Y does not belongs to B union C. This means that Y belongs to A, and if Y does not belongs to B union C, that means Y does not belongs to B and Y does not belongs to C. Now differentiating these results, so Y belongs to A and Y does not belongs to B, and Y belongs to A and Y does not belongs to C. So this is now Y belongs to A minus B, and means intersection, and this means A minus C. Therefore, we can say this is a subset of this set, right? Now, from these two results, these are subsets of each other, and therefore we can say that the two sets are equal. Clear? Now, next is, in next questions, we have to determine whether the statement is true or false. So, question 13th is that A minus B union A intersection B is equal to A. So you can check it by using Venn diagram. See, this is the set A, this is set B. Now this portion only is A minus B, that is only A, and this portion is A intersection B, and union of these two portion is the set A, right? So now by Venn diagram we know that this is a true statement, right? Now we will prove it. So A minus B union A intersection A minus B union B. We have used distributive law. Now A minus B is this portion, and its union with the complete set A will be set A intersection A minus B union B. This is the set A minus B, and this is the complete set B. So union of these two will be A union B, and intersection of A intersection A union B will be A. So this is equal to A. True. Now second is A minus B minus C is equal to A minus B minus C. We have to check if it is true or false. So again using Venn diagram. So we will first draw the Venn diagram of this left hand side. Now this is the set A, B and set C. We want A minus B minus C. So first of all calculating B minus C. B minus C means that portion which is in B but not in C. So see this portion. So this portion is which lies in the set B but not in set C. We will not take this part because it lies in C. So this is B minus C. Now A minus B minus C will be that part of A which is not in B minus C. So except this, because this part is in B minus C, all the other part of A will be A minus B minus C. Now we will calculate A minus B minus C. For this, first of all, calculating A minus B. So A minus B will be this portion of A, right? We will not take this portion because in this portion B is also there, right? So this is A minus B. Now we want to calculate A minus B minus C. That is that part of A minus B which does not include C. So see, this is A minus B, but this portion lies in C. So leave this portion also. This is A minus B minus C. As we can see, these two shaded portions are not equal. Therefore, we can say that this statement is false, right? Now next is, if A is a subset of B, then A intersection C is a subset of B intersection C. If you want to check it by Venn diagram, you can check it. This is true. We will prove it. See, to show that this is a subset of this, take X belongs to A intersection C. Intersection here means that X belongs to both A and C. Since A is a subset of B, it is given. So if X belongs to A, then it implies X belongs to B and X belongs to C. So it implies that X belongs to B intersection C. Therefore, this is a subset of B intersection C. Therefore, this statement is true. Now next is question number 17th. Question 17th is, if A is a subset of C and B is a subset of C, then A union B is a subset of C. This we have to show. So let X belongs to A union B. This means either X belongs to A or X belongs to B. Now if X belongs to A is a subset of C, so it implies X belongs to C, or similarly this also implies X belongs to C. So from both the case you get X belongs to C, and therefore A union B is a subset of C. Therefore it is true. Clear? We will revise some of the formulas. So first two are De Morgan's law. A union B whole complement is A complement intersection B complement. Second is A intersection B whole complement is A complement union P complement. Third is, this is not the De Morgan's law. A minus B is equal to A intersection B complement. A minus B is equal to, in place of minus, take the intersection, and in place of the second set its complement will come. So A minus B is equal to A intersection B complement. We can also check it by Venn diagram. So see, this you already know, this is A minus B, the portion of A which does not lie in B. Now B complement is the complete set which does not includes B, that is this portion, right? Now B complement intersection we have to take with A. So you can see this is B complement and its intersection with A is this part only, right? So this and this are equal. Therefore A minus B is equal to A intersection B complement. Now we have to use properties to prove these results. So first, question 18th is that A union B minus A is equal to A union B. So by using property, first of all, we have just understood this formula that B minus A, we can write it as B intersection A complement, right? Now using distributive law, A union B intersection A union A complement is equal to, now A union B as it is, intersection union of A and A complement. So union of these two is universal set, and intersection of any set with the universal set is the set itself. So it is equal to A union B. So we have proved this by the property. Question 20th is A minus A intersection B is equal to A minus B. Again taking LHS, A minus, this is A intersection complement of the second set. So A intersection B whole complement. Now before using distributive law, right, we have to solve this complement. So solving it by De Morgan's law, you can write here in the bracket also that by De Morgan's law. A intersection B whole complement will be A complement union B complement. Now we have applied the distributive law. Now this intersection of A and A complement is obviously phi union, because we want to show it equal to A minus B. So writing this again as A minus B. Now phi union, this will be the same set A minus B. Clear? Question number 21st, that A union B minus B is equal to A minus B. So taking LHS, this will be A union B intersection B complement, right? Now distributive property, A intersection B complement union B intersection B complement. This will be phi, and writing this as A minus B. Union of these two will be A minus B. Now solution of question 24th. Let EMS denotes the set of students passed in English, Maths and Science respectively. Now this is the information which is given in the question, that number of students studying English is 15, Maths is 12, Science is 8. Intersection, that is number of students studying Maths and English, is 6. Maths and Science is 7. English and Science is 4. And all the 3 subjects is also 4. So see, first of all, we will make the Venn diagram using this information. Now making Venn diagram. Students studying all the 3 subjects is 4. So first of all, fill this. Now students studying English and Maths is 6. So 4 is already there. This portion is the intersection of English and Maths. 4 we have already written. So write here 2. Then English and Science. Number of students studying is 4. We have already written 4. Here 0 will come. And Maths and Science is 7. So Maths and Science is 7. 4 is already there. So 3 will come. Right? Now number of students studying English is 15. 6 we have already written. So write down 9. Similarly, number of students studying Maths is 12. We have written 4 plus 6, 4 plus 2, 6 plus 3, 9. So 3 will come, and similarly here 1 will come, right? Now we have to find who passed in English and Maths but not in Science. See, English and Maths is this portion complete, but we want English and Maths but not Science. So we will not take this 4. Why? Because in this those students come which also passed the subject Science. So the answer will be 2. In Maths and Science but not in English. So the same as above. In Maths and Science. So Maths and Science. That is this portion. But not in English. So we will not take this 4. The answer will be 3. Now in Maths only. In Maths only. That is this portion. So 3. In more than one subject. Number of students passed in more than one subject. So see, this 9 shows the number of students passed in English only. So that is one subject. This also shows one subject. This also shows for one subject. So we will not take these 3, right? Now this 2 shows 2 subjects. This 0 and 3 also shows that the student passed in two subjects, and this 4 shows that the student passed in all the 3 subjects. So we want in more than one subject, that is either in 2 subject, that is 2 plus 0 plus 3, and either in the all the 3 subjects, that is this 4, So the answer will be 9. Clear? Now the question number 25th, in which the universal set is given as 60, number of people who play cricket is given as 25 and who play tennis is given as 20, and number of people who play both the games is given as 10, and they asked to find the number of people who do not play cricket and who do not play tennis. That is the number of people who does not play any of the game. That is, we have to find number of elements in C complement intersection T complement, which we know is by using the De Morgan's law. This will be number of elements in C union T whole complement, right? And this will be number of elements in U minus number of elements in C union T. Now number of elements in the universal set is 60 minus, with this information we can find number of elements in C union T, which is number of elements in C plus number of elements in T minus number of elements in the intersection. So the final answer you will get as 25. Clear? Question number 26th. So all this information is given that number of students in a group is 200. So it is a universal set. Those who study maths are 120. Physics are 90. Chemistry are 70. Maths and physics are 40. Physics and chemistry are 30. And chemistry and mathematics are 50. So all this information is given. Also this is given that 20 study none of the 3 subjects. So none of the 3 subjects mean neither maths nor physics and nor chemistry. So it will be number of elements in M complement intersection. We will take intersection because they are not studying maths and also physics and also chemistry, right? So intersection will come. Intersection P complement intersection C complement is equal to 20. Right? Now we have to find number of students who study all the 3 subjects. That is, we have to find number of elements in M intersection P intersection C. Right? This is only the number of students who study 3 subjects. So for this, first of all, we will find union. That is, number of students studying at least one of the subject, which will be this number of elements in M union P union C. Now this will be equal to, because we have given this information, so we will use this information to find out this. So this is nothing but number of elements in the universal set minus its complement, and its complement will be this only, M complement intersection P complement intersection C complement. Or you can also see that these are the students which do not study any subject. So universal minus this number of students is equal to 180, which are those students which study at least one of the subject, because only 20 students study none of the 3 subjects. Rest maybe study one subject or 2, but they must be studying at least one of the subject. Clear? So this is now 180. Now using this formula and all the information given, we will find the number of students studying all the 3 subjects. We want to find this, right? All this information is already given. This we have calculated as 180. So write down all the values. 180 is equal to all the values which are given minus this. So when you will solve it, you will get it as 20. So 20 students are studying all the 3 subjects. Clear? So this is the solution of chapter 1st from NCERT exemplar. So your today's homework is to check your answers carefully, and if there is any mistake in your answers, correct them. Okay? Thank you.